Okay, let's resume. We talked about this example about drying time of a certain paint in the previous video. And the null hypothesis was about the same as before. Before means the past value, about the same as 75 minutes, the traditional value. An alternative hypothesis in this case was significantly less than 75 minutes. You can see this alternative hypothesis is less than, not greater, from these two. You got 72.3, which is less than 75. That's number one. And number two, which is even stronger indication, designed to decrease the drying time. So we have to take mu is less than the traditional value. That's how we set up hypothesis. And let's try this kind of example once more. And here's the next example. 2.4. One of the best indicators of baby's health is the weight at birth. In the United States, mothers who live in poverty generally have babies with lower birth weights. Although the average birth weight for babies in the United States is about 3,300 grams, the birth weight for babies of women living in poverty is 2,800 grams with a standard deviation of 500 grams. Recently, a local hospital introduced an innovative new parental care program to reduce the number of low birth weight babies born in hospital. At the end of the first year, the birth weight of 20 randomly selected babies were collected. All of the babies were born to women who lived in poverty and participated in the program. The mean birth weight was 3,060 grams. Okay, we have to set up hypothesis based upon this question. Has there been significant improvement in the birth weight of babies born to poor women through this new innovative parental care program? And you have to set up hypothesis. Okay. Alternative hypothesis is relatively easy to set, I think, in this case, because the question is about whether there was an improvement or not. Improvement, which means, well, did it get better? Or this baby's got heavier, more birth weight. So we're talking about this kind of situation. But then again, what is mu naught value? Well, there are many competing gram values here except for this one. The standard deviation of 500 grams, that's obvious, that's obviously out. And there are 3,300 grams, 2,800 grams, and 3,060 grams. Which one is it? That's the question. It turns out the real mu naught is this one, 2,800 grams, because this is the one that is associated to the standard deviation. You see, 2,800 grams with standard deviation of 500 grams. They're both about a population. And this population in this case is women living in poverty. How about the average birth weight here? Well, this was just given, but no standard deviation was given here. Well, there's an indication that this is just bogus figure or just there to confuse you. Is it really mean? Actually, no. As a matter of fact, if you have real life example problems, then there's too many informations and it's going to be a big deal to select appropriate information and trim out other unimportant information. There are really a lot of those. Here, we are just trimming out just one number. Hey, that's fair. There's nothing mean about this kind of thing. This one, 3,060 grams, that'll turn out to be important. And this one is associated to the sample of 20 randomly selected babies. So this is going to be associated to setting up the alternative hypothesis. In short, we have something like this. 2,800 grams. That's for the women living in poverty before introducing this innovative new parental care program. Now, what is after figure? 3,060, but that's not alternative hypothesis. Alternative hypothesis, whether it is greater than or less than 2,800. It's like this. Significantly greater than 2,800 grams. Well, how do we know? Well, number one is whether there is an improvement, significant improvement. Number two, sample study got 3,060, which is greater than 2,800. That's how we know H0 is about the same as 2,800. It's the same figure as before, status quo. And alternative hypothesis is, hey, there's an improvement bigger than that. Exactly how do we visualize all these? Well, here we go. Oops, I have to open it up. We have a normal picture around 2,800 because that's a null. And then the sample study actually gave us 3,060, and how far is sufficiently far away? How close is close? Well, that's something we'll have to discuss a bit later, probably in the next video. Okay, we have a little bit more time, so let's discuss 2.5. This is one of those rare cases where we have to consider the two-tail. This kind of instance, this kind of situation. Let's see. In the previous problem, the same problem as 2.4. Set up the hypothesis based upon the question: is there sufficient evidence to declare that the new parental care program made a difference? Here, the difference refers to mathematical difference, not for the better or for the worst. I mean, this problem really looks like distorted problem, really mean problem created by a math teacher who just care about mathematics, not the real life explanation, real life application. And that's true. I am a math teacher, and I created this problem just to get something about the final case, which is relatively rare, because in real life case situation, it's very difficult to create an example like this. So I just distorted this problem kind of like this, and here's the solution. About the same as before, alternative hypothesis different. Now, why would anyone consider just pure difference, not for the better or for worse? Well, there's a typo, excuse me. Not for the better or for worse? Well, beats me. Well, two-tailed tests are rare, relatively rare. Okay, here is a visualization. We have normal picture around 2,800, and then 3,060 is relatively far away or close enough to the null. Depends upon kind of threshold. How far is far enough and how close is close enough, which we call the level of significance. We're going to talk about those in a separate video. Okay, in short, we talked about the mathematical structure of hypotheses, and here they are, and please remember these. This is a starting point of the hypothesis testing, which is arguably the most important topic for the entire semester. Null is approximate equal, and alternative hypothesis is usually significantly bigger or significantly less. In some cases, there is a difference or not, but that's rare.